morning, students. Yes. Basic concepts related to organic chemistry. Right? So that's what we were discussing. Basic concepts related to organic chemistry. So good morning. So today it is very cloudy, right? So we don't know what is happening at Chennai. Okay, now? So okay, with respect to the syllabus for the test, with respect to organic chemistry, we will be having up to homolytic cleavage, heterolytic cleavage and all. So once again I will tell. So when it comes to your test, with respect to organic chemistry, I am talking about test portion. With related to organic chemistry, so it will be IUPAC nomenclature, it will be there, then isomerism, it will be there, then with respect to classification, it will be there. Okay, so then we have homolytic cleavage, homolytic and heterolytic cleavage. All these things will be there. Okay, and focus majorly on these two. Very important. Got my point? So those two will be very important for your exam point of view. Any doubts with regard to this? Fine. So these are the topics related to your test in organic chemistry. In organic chemistry. Okay. Okay, Ashish. Done. So this is related to test portions. You have to perform well. Okay. So we will move to today's class, and before that, can any one of you tell me what we had discussed in the last class? Can any one of you? What we had discussed in the last class? Just points. Okay, very good. As Gauri has written, first we went with the resonance, then we discussed about inductive effect. Okay, that's why we have the inductive effect. So what is the speciality of inductive effect? Inductive effect can also involve sigma bond. It is observed with respect to sigma bond. But when it comes to resonance, pi electrons are required. But here, sigma bond will also, or sigma bond can also be involved. Okay? So that's where we have the inductive effect. When I am talking about inductive effect, same as that of the resonance, so we can classify the element into electron donating groups and electron withdrawing groups. Electron donating groups. EDG means electron donating groups. Right? And what about another one? Another one is electron withdrawing groups. Electron withdrawing groups. Okay, now? Whenever electron donating groups are there, now it will be considered as positive inductive effect, because symbol will be I. So it will be called as positive inductive effect. If electron withdrawing groups are there, then it will be called as negative inductive effect. Okay, so positive inductive effect and negative inductive effect. Now, when I'm talking about positive inductive effect, so that's what where I have taken the example of. Can anyone remember? I have taken the example where three methyl groups will be attached. Three methyl groups will be attached to that carbon which is next to the carboxyl carbon. Which is next to the carboxyl carbon. What is the specialty of this methyl group? They are electron donating groups. They are electron donating groups. What is the name of this molecule? We can call it as 2,2 dimethyl propanoic acid. Propanoic acid. So that's where we have the molecule. Okay. So what is the impact? What is the impact of the methyl group with respect to acidic character? Whether this molecule is a strong acid or a very weak acid, which type of acid it is. Whatever I have written on the board, whether it is a strong acid or a very weak acid. Anyone? Yes, Bhumika, absolutely correct. It is a weak acid. Very good. It's a weak acid. That is the reason, or that is the impact of inductive effect. That is the impact of inductive effect. Positive inductive effect. All of you correct. So why they are behaving as a weak acid? Because of the positive inductive effect. Because electrons are moving away from the methyl group. Electrons are moving away from the methyl group. Got my point? So that's where we have the one of the inductive effect, impact of the inductive effect. Okay. Now I have taken another example. ClCOOH. So which is this molecule? So this molecule is nothing but trichloroacetic acid. So this is nothing but trichloroacetic acid or ethanoic acid. Anything is fine. So trichloroacetic acid. TCA. Yes, Bhumika, absolutely correct. TCA. Whether it is a strong acid or a weak acid. Whether it is a strong acid or a weak acid. Anyone? Whether it is a strong acid or a weak acid. Strong acid. Yes, absolutely correct. It is a strong acid. It is a strong acid. What is the reason for the strong acid character of this molecule? All of you correct. It is a strong acid. That is because due to the presence of electron withdrawing element, that is chlorine. Okay, so electron withdrawing group. So that's where due to the inductive effect, negative inductive effect, this will behave as a strong acid. Due to the negative inductive effect, it will behave as a strong acid. TCA. Okay, so that is the impact of the inductive effect. And if you observe whatever example I have taken, everything where sigma bonds are involved, no pi bonds. Sigma bonds are involved. That shows the inductive difference between resonance and inductive effect. Resonance is majorly with respect to delocalization of electrons. But when it comes to inductive effect, it is the pulling of the electron by the electronegative or electron donating impact by the electropositive elements. Got my point? So that's where we have the inductive effect. The inductive effect can be due to electron donating groups or electron withdrawing groups. But when it comes to resonance, there is no question of always there should be involvement of substituents. No. Whether I am clear? So what I mean to tell you is if I want to see the difference between inductive effect and resonance, Inductive effect and resonance. Okay. So in one case, sigma bonds will be involved. Sigma bonds will be involved. Okay. But here only with 5 electrons. Only with the 5 electron. Okay. So inductive effect can happen in the presence of electron withdrawing group or electron donating groups. Electron withdrawing groups or electron donating groups. But when it comes to resonance, there is not compulsory, but there should be presence of alternate double bonds. There can be presence of alternate double bonds. Okay, so that's where we have the difference between inductive effect and resonance effect. But in both the cases, we have positive resonance, negative resonance, positive inductive effect, and negative inductive effect. It will be there. Okay, so that's where we have the difference between inductive effect and resonance effect. Okay, any doubts in this? Any doubt with respect to these concepts? That is inductive effect and all, whatever we have discussed. I will go with another example, but until that one, any doubts in this? Okay, okay then if I take another example, yesterday I told we have phenol. We have the phenol. Okay, benzanol or phenol. If I take phenol, it is stronger acid compared to other alcohols. In the sense I am talking about alkyl alcohols. What do you mean by alkyl alcohols? It can be methanol, ethanol, anything where alkyl group will be there. Say for example, alkyl in the sense it can be methyl derived from the alkane methane, or it can be ethyl derived from the alkane ethane. So that's why they are called as alkyl groups. Propyl, ethyl, butyl, they are all alkyl groups. So alkyl alcohol means where OH group is attached to these any of these alkyl groups. So compared to them, phenol is a strong acid. Right? So what is the reason? That is because whatever intermediate will be formed, intermediate in the sense after donating the H plus, whatever product will be formed, which is a phenoxide ion, So this will be stabilized by resonance. Which will be stabilized by positive resonance, to be more specific. It will be stabilized by positive resonance, right? So where the movement of the electron will be from the oxygen, that is from the substrate, towards the ring. So that's why it will show the positive resonance. All of you have understood? So therefore, due to the stability of the phenoxide ion, therefore OH of phenol, it can be easily dissociated as O minus and H plus. O minus and H plus. And that's where we can observe impact of the resonance effect on the property of a molecule. Impact of the resonance effect on the property of the molecule. All of you got my point? Okay, same logic is applicable. Why carboxyl group can donate the H plus so easily? That is because once they will get dissociated, now there will be O minus, right? So now they can show the resonance. Now they can show the resonance. Bond, double bond can be here or here. So that's what I can see. So due to the presence of resonance, once this H plus is released, so therefore carboxylic acid can behave as an acid. So they are all basic concepts. If you understand these things, you can easily understand the property of a given molecule. Okay? So that's where the impact of the resonance, where carboxylic acid can release the H plus to form the carboxylate ion, which will be stabilized by the resonance. How come we are telling resonance? Because double bond can be here or double bond can be here. There's a delocalization of electron is taking place. Okay, Rakesh, I will write. Okay, so what I mean to tell here is, as same as that of the phenol and phenoxide, same way we have the carboxyl group, right? Now this carboxyl group can be easily dissociated as carboxylate. Okay. Now this carboxylate can be present in two different forms. It can be present in two different forms. What is happening? So double bond can be here or double bond can be here. Both the forms can be there. So there is a delocalization of electrons. Pi electron is taking place. But when it comes to carboxylic acid, when H is attached, this cannot be possible. So due to that, carboxylic acid can behave as a acid, acidic functional group, same as that of the phenoxide. Where phenol will donate the H plus and phenoxide ion will be stabilized by resonance. Fine? Any doubt whatever I have told now? Shall I move to the next one? So these are all some of the examples where you can apply the resonance effect in organic chemistry. You can apply the resonance effect in organic chemistry. Okay. Now that's what phenol will behave as a strong acid among the other alcohols, especially with respect to alkyl alcohol. Yes, well. Then we will move to next one. Now I have a molecule. Now I have a molecule. OH group is there. Okay. And now it is having CH3. It is having CH3. Okay. So it can be called as a 4-methyl phenol. We can call it as 4-methyl phenol. 4-methyl phenol. Or if I'm going with toluene as the parental molecule and later OH group is attached, then we can call it as 4-hydroxytoluene. 4-hydroxytoluene, but we'll consider phenol as the parental molecule. Okay, so 4-methyl phenol. In this case, I have a substituent which is called as methyl group. Right? Now, what is the speciality of the alkyl group? What is the speciality of the alkyl group? They are electron donating groups. They are electron donating groups. So they will show the positive resonance. They will show the positive resonance. Right? They will show the positive resonance. Then they can show the positive inductive effect. They will show the positive inductive effect. Now, due to the substituent effect is that, therefore, inductive effect will come into the picture. Okay, board is for everyone. Board is not clear. Because for me, It's clear, Geeta, but I will just check it out. 1 minute. Geeta, now it's clear. I have reduced the light. Yes, Rakesh, I will write big. Now whether it's clear? 1 minute. Oh, I will write big. Don't worry, I will write big. So what I was telling here is, I have the OH group. Now it will be attached with the methyl group. It will be attached with the methyl group. It's a phenol derivative. If I consider this one as a phenol derivative, okay. Now you can see methyl group will have the positive resonance effect. That means electrons are moving towards the ring. Electrons are moving towards the ring, as same as that of the OH group. Electrons are moving towards the ring structure. Now, along with that, since electrons are moving away from the substituent, positive inductive effect. We can call it as positive inductive effect. Right? So that's where. Now, can you tell me, if I want to compare acidic character of phenol, and this molecule, so which will be a stronger acid? 4-methylphenol, or it will be phenol, which will be a stronger acid? Can any one of you, which can be a stronger acid? Okay, Geeta, she has not responded. Whether it's clear now, Geeta? Whether board is clear? Now in the meantime, you can give the answer. Among these two, which will be the stronger acid? Phenol or 4-methylphenol? Anyone? And in the meantime, I want Geeta to respond. 4-methylphenol. According to Ashish, 4-methylphenol will be a stronger acid. All of you will agree? According to Ashish, 4-methylphenol will be a stronger acid, it seems. All of you will agree with that? Yes, sir. Clear. Okay then. Okay. Now, we will come back to this concept then. Now, Ashish is telling 4-methylphenol is the stronger acid. Even Shubhangi, Bhumika, oh, all of you are going with that. But I will tell that phenol will be the stronger acid. Phenol will be the stronger acid because due to the presence of electron donating group, this bond will be not become weak compared to here. Got my point? So due to the presence of electron donating group, same as that of 2,2-dimethyl propanoic acid, if you recollect, 2,2-dimethyl propanoic acid, due to the presence of electron donating group, if you recollect, that's what I have taken the example, CH3, and COOH. And I told this one as a weak acid. What is the reason? Due to the electron donating groups. Right? So due to that, it will be a weak acid. Same logic is applicable here. Same logic is applicable even for this particular case. Got my point? So due to the presence of alkyl group, OH bond will not be dissociated easily. Okay? So due to that, this particular molecule will be slightly weaker acid compared to phenol. All of you got my point? Okay. Any doubt in this? It's very simple. So here also it is also donating the electron, it is also pushing the electron. So therefore, since electron is coming from this side also, due to that this OH bond will not be cleaved easily. Whether I am clear? Ashish, you had asked how it's possible. That's where I am giving the explanation. So you can tell that 4-methylphenol or 4-hydroxytoluene will be a weaker acid compared to phenol due to the positive resonance and positive inductive effect. Okay, and always remember inductive effect is going to dominate compared to resonance effect. When they are coming together, inductive effect is going to dominate. Fine. So this is what one explanation. One of the application of inductive effect concept. One of the application of inductive effect concept. Now I have another molecule. I will take this one as okay. So can any one of you tell me which is this molecule? Whatever I have written on the board, which is this molecule? Which is this molecule? Whatever I have written on the board, just the name of the molecule I want. Oh, Vasanta, you are late. Okay. So, which is the name of this molecule? Can any one of you? Left side one is phenol, but what about this one? What is the name of the molecule? Wow. Whether signal is weak or my students are not sending the answer. Name of the molecule is, now I am going to write, name of the molecule is 4-nitrophenol. Name of the molecule is 4-nitrophenol. That's where we have the name of the molecule. No Shashank, it's not nitrile, nitro. When I am using it as a suffix, prefix, it will be nitro, 4-nitrophenol. Okay, Shashank, it should not be written as nitrile. Nitrile means CN, cyanide group. It will be called as nitrile. But here it is NO2. So nitro group, not nitrile. So fine. So whether I am clear? So that's where we have the 4-nitrophenol. 4-nitrophenol. All of us we know that nitro group is a electron withdrawing group. Nitro group is a electron withdrawing group. If you go back to resonance, nitrobenzene, I told nitrobenzene will show anyone? Nitrobenzene will show which type of resonance? Positive or negative resonance? Nitrobenzene, it will show positive or negative resonance. We have discussed this one. Nitrobenzene, whether it will show positive or negative resonance. Yes, it will show the negative resonance where electrons will be moving toward the substituent away from the benzene ring. So therefore it will show the negative resonance. Okay. Now here it is positive resonance and here it is negative resonance. Right? So So with respect to phenol, they will show hydroxyl group positive resonance. But here it will show negative resonance. Now we have to talk about inductive effect. We have to consider the inductive effect. This is with respect to resonance effect, with respect to substance. What about inductive effect? Inductive effect will be negative inductive effect. Inductive effect will be negative inductive effect. Now, due to this reason, which one will be a stronger acid? Whether it will be phenol or whether it is 4-nitrophenol, which will be a stronger acid, right? So negative inductive effect, negative resonance effect will be shown by NO2 as a substituent, OH as a substituent, it will show the positive resonance effect because electrons will be moving towards the ring. Hagadre, you should tell me which will be stronger acid, 4-nitrophenol or phenol? Which will be the stronger acid? Yes, yes, Shashank. 4-nitrophenol will be the stronger acid. 4-nitrophenol will be the stronger acid, no doubt. That is because of the negative inductive effect. That is because of the negative inductive effect. As I told, when resonance and inductive effect, they will behave opposite, inductive effect is going to dominate. But here, both are going parallel with each other. So naturally, it should behave as a strong acid compared to phenol. Now I have another molecule which you are going to study in your second PU. A very important molecule for our examination point of view in second PU. Okay, so NO2, NO. So now, can any one of you tell me IUPAC name of this molecule? Common name. If I want to you to tell the common name, it will be picric acid. It is a picric acid, not picnic. Don't write picnic. It is picric acid. What is the IUPAC name for picric acid then? In second PU they will ask 1 mark question. IUPAC name of picric acid. So what is IUPAC name? Can any one of you tell me? Can any one of you tell me which will be the, what will be the IUPAC name? Ashish. Trinitrophenol I can understand, but you should give the number. Now Shashank is right. You should give the number, okay? That's very important. So that is 2, 4, 6. Trinitro, as you people have written, trinitrophenol. That is the IUPAC name of picric acid. That is the IUPAC name of picric acid. Whether picric acid will be much more stronger acid compared to 4-nitrophenol? Whether picric acid, yes, all of you are correct. It is 2,4,6 trinitrophenol. So in that case, whether picric acid is much stronger acid compared to 4-nitrophenol, yes or no? So whether picric acid will be much stronger acid compared to 4-nitrophenol? Yes, of course, picric acid will be much stronger acid compared to 4-nitrophenol. Picric acid will be much stronger acid compared to 4-nitrophenol because 3 nitro groups are attached. There will be 1, but then it is 3. So due to that, due to negative inductive effect, due to negative resonance effect, picric acid will be much stronger acid compared to 4-nitrophenols. So 4-nitrophenols. All of you got my point? Any doubt in this? So that's where we have the impact of inductive effect. That's where we have the impact of inductive effect. Fine. So now we can conclude that based on the type of substituents, based on the type of substituents, property of a given compound will be decided. Property of a given compound will be decided, right? I have taken the example of phenol and its derivatives. I have taken the example of phenol and its derivatives, right? And we saw when I am talking about phenol, nitrophenol, then trinitrophenol, right? Then I have taken the methylphenol, or we can take toluene as the parental one. In all these cases, properties will change because of different substituents or different number of substituents. So what I mean to tell here is, as the number of nitro group substituents will increase, acidic character of OH group will be much more increased. So number of the substituents is going to decide whether increase or decrease in the acidic character of the phenol. Okay, so that's what the impact of inductive effect on a given organic compound. On a given organic compound. Any doubts? Any doubts with respect to the inductive effect and all? Okay, so in that case, shall I move to the next one? That will be last part of your organic chemistry. But any doubt up to here? Okay. The last part will be electromeric effect. Electromeric effect. Okay. So electromeric effect can be, symbol can be E. Symbol. Inductive effect symbol is I. But here it is symbol will be E. Okay. Now electromeric effect will be observed. Sir, the chapter is so tough. Sir, how to study? Rohan, maximum by tomorrow another 15 minutes it will be done tomorrow. This chapter will be completely done. Then we have some revision classes. Don't worry, I will tell you how to read. Okay, I will tell you. It's not tough, it's easy only. But as a student, yes, you may feel it's tough, but I'm going to revise the topic and I will tell how to write the answers. Fine? So don't worry. So up to Saturday we have the time, right? So we'll have the revision class based on this. And you can inform your friends also. Okay? Break and study the concept. Okay? Each and everyone, they are having their own way of study. Okay? Anyway, we will revise it. And how to write the answer, how to understand the concept, I will tell you. But very important one is, you should understand the concept, that's all. But anyway, we will have a discussion on this. Fine? So however, when I am talking about electromeric effect, once again it will be found when there is a presence of pi electrons. When there is a presence of pi electrons, are there? In that case, what is the difference between electromeric effect and resonance effect then? But in resonance, there was a requirement of conjugated double bonds. Conjugated double bonds, where in case of the resonance, which is not required in electromeric effect, which is not required in electromeric effect. There is just a requirement of pi electron, that's it. No requirement of conjugated double bonds, which was required for the molecule to show the resonance effect. Okay, that's where the difference between electromeric effect and the resonance effect. That is one thing. Another important thing here is electromeric effect will be observed in the presence of attacking agent. It will be observed in the presence of attacking agents. Okay, see one simple example. If I take a benzene ring, okay, benzene ring alone, whether benzene ring alone will show the resonance? Yes or no? Benzene as alone, single molecule, whether it will have the resonance or not? Whether benzene as alone, single molecule, whether it will show the resonance, yes or no? That's what I want the answer. Okay, so no. Bhumika, Ashish, all of you are telling no. Okay, so you mean benzene ring will not show the resonance in the absence of attacking reagent? That's what you are telling? Benzene ring will not show the resonance in the absence of attacking reagent. That's what you are telling? Yes? In the absence of attacking agent, benzene ring will not show the resonance feature. That's what your conclusion? Yes? Okay. So in that case, I can tell that you people are wrong. It's wrong because when I'm talking about benzene alone, I can draw the benzene like this, or I can draw the benzene like this. Both are correct. Both are correct. So that's where we are showing that one by resonance hybrid structure like this. Can you observe here? Double bond positions, they are different. No need to number because there is no substituent. But you can see there is a double bond position which are different in these two. But still, we have a benzene, right? There is no substituent. There is no attacking agent, but still, benzene can show the resonance features. It can show the resonance features, right? Due to the presence of alternate double bonds. That's what I told. Resonance is respect to delocalization of electron. That means movement of electron among these alternate double bonds. So that can be present in the absence of attacking agent also. But when I'm talking about electromeric, when I'm talking about electromeric effect, it will be shown whenever there is a presence of attacking agent. The movement of electrons will take place whenever attacking reagent will approach the molecule. Try to understand these things properly. Whether I am clear now? All of you have understood? So what is that difference between electromeric effect and resonance? Electromeric effect will shown by those molecules which will be having pi electrons, no doubt. Now, when it comes to resonance, the basic requirement here is conjugated double bond should be there. That is one thing. And another thing here is electromeric effect will be observed in the presence of attacking agent. But resonance will be observed whether attacking agent is there or not. Resonance will be there. Okay? So got my point? So that's where we have the difference between electromeric effect and resonance effect. Okay? When I'm talking about electromeric effect, we have to go with some of the examples. We have to go with some of the examples. For example, I have a alkene. I have a alkene. Okay? Now, this alkene, I want to add HCl. this alkene, I want to add HCl. Okay? Since there is an unsaturation, addition reaction can take place. What do you mean by addition reaction? Addition reaction means nothing will be removed. Try to understand all these things. Addition reaction, once again you are going to study in your hydrocarbons topic. So what do you mean by addition reaction? Nothing will be removed from this molecule. Instead of that, there will be addition of extra element to this. So therefore it is called as addition reaction. So what do you mean by addition reaction? If I consider this one as a eth, CH, 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 that means I am talking about CH2 double bond CH2. That means I am talking about eth, a alkene. Okay. Now if I talk about eth in this case, during the reaction, once the product will be formed, nothing will be removed from this particular ethane. Instead of that, there will be addition of extra element. That's why it is called as addition reaction. That's why it is called as addition reaction. Yes, go. It is C2H4. Okay. So that's why we have the addition reaction. Now observe it carefully. Since I am taking the HCl, there will be formation of H plus Cl minus. There will be formation of H plus and Cl minus. Right? So one is electrophile and another one is a nucleophile. Another one is a nucleophile. All of you are getting my point. So two attacking agents from HCl. One electrophile, that is H plus, and another one a nucleophile, that is Cl minus. Now, before taking these attacking agents, there should be some arrangement among these carbon. They have to come to an agreement. They have to come to an agreement. So these two carbon, in the presence of attacking agent, in this case H plus and Cl minus. So this carbon will tell to this carbon that, my dear friend, what I will do is, I will take the electrophile with me. You take the nucleophile with you. That's why we'll go with the addition reaction. Got my point? So it is a symmetric molecule. Ethene is a symmetric molecule. So they will come to a agreement. These two carbon will come to an agreement that this carbon will tell to this carbon that, my dear friend, I will take the electrophile with me, you take the nucleophile with you, so that we can go with the addition reaction. Got my point? Now, since this carbon is ready to take the electrophile, that means it should have the extra electron with it, because electrophile does not have any electron in it. It's a deficient species, electron deficient species. So due to that, this carbon, if it is taking the electrophile, if it is ready to take the electrophile, then this should have the extra electron. It should have the extra electron. So due to that, it will tell to this carbon that I will take the electrophile. So whatever pi electron is there, even your electron, you give it to me. That's what? Homolytic cleavage. That's where homolytic cleavage. See the reaction. That's where the homolytic cleavage. Now this carbon will not quarrel. It will agree for this particular agreement, because this nucleophile will tell to this carbon that you give the electron, I am here to donate the electron to you, because I am rich with electron. So don't worry, I will donate the electron to you. So whatever is there, you give it to this carbon. That's what chloride will tell to this particular carbon. You are getting my point? So now that's where nucleophile will come to here. Nucleophile will come to here. All of you have understood? Any doubts? Any doubts with regard to this one? And that's where we have a addition reaction. That's where we have a addition reaction where one carbon will be attached with 3 hydrogen and another carbon will be attached with 2 hydrogen and 1 chlorine. Right? So that is nothing but CH3, CH2, Cl, ethyl chloride. Ethyl chloride or chloroethane, or you can call it as chloroethane. I will paste the name. Chloroethane. Any doubt in this? What is happening here? That's where we can see the electromeric effect. There is a shuffling of electron is taking place. Depending on which attacking agent is coming to the carbon, either it is taking the electron or it is donating the electron. Okay? So in this case, if I consider this one, numbering simply I am giving, this is a symmetric molecule. I will call this one as carbon 1, I will call this one as carbon 2. Okay, in the product chlorine is present there. Na? So I will call this one as carbon 1. Okay, and this one as carbon 2. Okay, now what is happening? So carbon 2 is taking up the electrophile, which is the electron deficient species. So whatever pi electrons are there, one electron belongs to carbon 1, even that will be taken by this particular carbon 2. Okay, so during that process, since this has lost one electron and this has gained one extra electron, so therefore it will gain the negative charge, it will gain the positive charge. So that's where we have a condition CH, 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 right? So that's where negative, that's where positive. Why this one has become carbanion? Because it has gained the extra one electron. So there is a presence of lone pair of electron. So why this lone pair of electron? One belongs to this carbon only, another one belongs to this carbon actually. Right? So why it has gained? Carbon 1 has gained positive charge because it has donated its one electron to this carbon. Okay, so therefore carbanion, carbocation, both will be formed during the process. And they will be immediately attacked by H plus. Naturally, electrophile will go to electron rich region, nucleophile will go to electron deficient region. So that's what it is happening. Okay, that's what it is happening. Any doubt? If you have any doubt, you can ask. So therefore, if I consider H plus, then it is called as positive electromeric effect. Okay. So with respect to H plus, it is a positive electromeric effect because where the attacking agent is going to the same position, electrons are moving. So that's why it is called as positive electromeric effect. And if I consider chloride, in this case it is showing negative electromeric effect because chloride is coming here but electron is moving away from that. So that's why we have the positive and negative electromeric effect which we can observe simultaneously. Got my point? Anyway, I will stop here, but any doubt? If you have not understood, let me know. So what I mean to tell here is H plus, it is coming to carbon 2 and electron is also shifted to carbon 2. So therefore, positive electromeric effect with respect to H plus. And when it comes to chloride, it is coming to carbon 1. But electron is moving away from the carbon 1. So therefore, it is nothing but negative electromeric effect. Okay. So therefore, in this case, I can see electromeric effect positive and negative. Both is happening simultaneously. Both are happening simultaneously. Okay. And always, as we have seen here, when it comes to electrophiles as an attacking agent, they will show the positive electromagnetic effect, and nucleophile as the attacking agent, they will show the negative electromagnetic effect. They will show the negative electromagnetic effect. Fine. So anyway, tomorrow once again we will continue. I will go with some more examples. Don't worry. And then we can have the revisions. We can have the revisions. Fine. Okay. Don't think that it's tough topic. No. Don't worry. So tomorrow we'll discuss more. Tomorrow and on Saturday. Okay now? Shall I stop then? If you don't have any doubt, shall I stop then? Yes, thank you. Thank you everyone. Thank you. Thank you. Take care. Bye.